friends. I am Satish Lele. This video is part of my chemical process piping channel on YouTube. This video is about plot plan. The majority of process plants require a plot plan with somewhat less stringent and less complicated arrangements than a refinery. Equipment spacing requirements will vary with the type of plant and location. Plot plans are considered key documents to projects and are normally initiated in the pre-contract, conceptual and development stages of a proposal. After the contract is awarded for engineering, plot plans are developed at a rather rapid pace with very limited information. This early stage plot plan usually is very limited in detail, containing only enough dimensional data to define the outer limits of the available property selected for plant development. Located within the boundaries of the available property, rough equipment sizes and shapes are pictorially positioned, along with anticipated pipe rack configurations, structure shape and rough sizes. The plot plan at this level of detail is then used for constructability evaluation and is normally submitted to the client for approval. The piping engineer has to understand the concept of equipment layout and consideration. While preparing layout, the piping engineer should design a steady process, non-hazardous utility and facility. In general, the various process plants we come across are petroleum refineries, petrochemical complexes, fertilizer plants, and chemical and pharmaceutical plants which need special attention due to the nature of materials and products handled. Before starting the development of the plant layout, the following information is required: process units and capacities, the flow diagram indicating the process flow sequence, utility requirement, number of storage tanks and also open storage areas, raw material and product receipt and dispatch philosophy, covered storage required, number of flares as applicable, grouping philosophy for utilities. Information is also required for non-plant building like administrative block, laboratory, security, workshop, parking space, fire station, canteen, etc. Ideally, before site selection, the preliminary layout should be made. The data collected during the site selection stage shall be given due consideration at the time of the equipment layout. A few points to be considered are site location, map and area topography, geological and meteorological data, environment conditions relative to adjacent properties, proximity to railway, road, airport, soil conditions, prevailing line direction, source of water supply and the supply point with respect to the plot, electric supply point with respect to the plot, effluent disposal point and other drainages, material transportation railway entry point, approach roads, barge or ship dock, etc. Geographical factors like wind direction, temperature, rain, frequent thunderstorm and earthquake susceptible areas. Major consideration in plant layout. The most economical plant layout is that in which the spacing of the main equipment is such that it minimizes interconnecting pipe work and structural steel work. Normally, equipment should be laid out in sequence to suit the process flow, but exception to this arises from the desirability to group certain tanks, pumps, or perhaps to isolate hazardous operations according to statutory rules and regulations. The use of the single stream or multiple stream flow pattern will affect the layout. The major variables affecting the final layout are interconnected pipe sizes, insulation thickness, steel work spacing, matters of operational convenience, safety, eve of erection and maintenance, which calls for critical judgment on the experience and the study of existing and known limitation. Economics. Basically, economic consideration means installing the unit in the smallest possible space, consistent with the operability ease of pipe and material, structural sheets and concrete with the proper layout, considering further economies which can be achieved in way of pumping and utilities. Safety. Where toxic or hazardous materials are handled, layout may be needed to isolate a section of the planned equipment, which could be a possible source of hazard. It should be grouped together and, where possible, located separately from other areas of the plant, like furnaces, flare stacks, or other equipment containing naked flares. Mechanical equipment handling flammable or volatile liquids which could easily leak or spill out of the equipment, thus causing flammable conditions. However, such consideration should not override considerations of cost. Process considerations may require some items be elevated to provide gravity flow of material to accommodate pump suction requirement or NPSH. The other process consideration could be the limitation of pressure or temperature drop in the transfer lines deciding the proximity of the furnace, reactors, and columns. Operational. Thought should be given to the location of equipment requiring frequent attendance by operation personnel and the relative position of the control room to obtain the shortest and most direct route for operator. When on routine operation, however, the control room should be placed so that they are easily accessible and the indicators are easily readable. Generally, a batch or semi-batch process needs more attention by the operator, and therefore more consideration has to be paid to the ergonomics of the layout. Maintenance. The need to remove for servicing, retuning, or replacements, the heavy servicing equipment. The indivisible plant will dictate their location when access for cranes is called for regular or rotating and other machinery calling for dismantling. This often makes their grouping within the machine house desirable. The position of items needing replacement of internal spent catalyst, etc., or frequent internal cleaning has to be carefully considered. Constructional. The plot should be so designed that adequate access is available to lift the large items of equipment or columns into place. Such equipment is positioned close to the boundary limits, so that erection must take place from outside these limits. A careful check must be undertaken to ascertain whether space will be available at the time of erection for positioning the crane or lifting the delivery equipment, which is known, may well arrive fairly late in the construction program and therefore it has to be fitted into place after most of the surrounding equipment has already been installed. It is important that the insulation requirement be considered during the layout of the plant. The appearance or aesthetic. An attractively laid out plant with the equipment in rows, also economically laid out, gives an aesthetic appearance. The building, structure, and groups of equipment should form a neat, symmetrical, balanced layout consistent with keeping the pipe run to a minimum and allowing proper access for maintenance. The tower and large vertical vessels should be arranged in rows with a common center line. They should be of similar size, but if the diameter varies, due note must be taken of the building line. Manholes on the adjacent tower should be at a similar elevation and orientation to streams. These, as far as possible, should be made identical. Such arrangement for parallel streams or similar groups of process equipment requiring much for design work and also for construction and subsequently operation, but help in reducing the amount of standby equipment. Future expansion. Thought should be given to the likely expansion of both equipment and pipe work, so that additions can be erected and tested with a minimum interference to plant operations. On main pipe runs, it is desirable to leave 30% space. At least 30-meter distance from flame-proof plant area is needed for safe welding where no special precautions are needed. Buildings. Plant buildings should be kept to a minimum on the basis that most of equipment including pumps, heat exchanger boilers, cyclones, etc. may be safely installed in the open. The philosophy should be that the plant is supported on an open steel structure unless there is good reason not to do so. Thus it is to be installed in the open with centralized control facilities housed in buildings. Factors which determine the selection of enclosed buildings are nature and frequency of the operator's work, equipment, which requires frequent maintenance in adverse weather conditions. Extreme climate conditions may determine that the plant is to be kept in a building. Type of equipment. Expensive equipment and complex machinery should have some degree of weatherproofing. Nature of process. Plants handling dusty, explosive and combustible solid materials require a building. To prevent contamination, food, pharmaceutical and biochemical plants require to be in a building. Proximity of hazards. To prevent the possible spread of fire and explosion, the building may be desirable. If enclosed buildings are planned, then consideration must be given to the following factors. Fire protection or explosion protection approval by the local fire authority must be obtained on firefighting equipment and layout. Illumination. Natural illumination may be obtained by the use of patent glazing windows for translucent sheets in the side walls or the roof. Artificial lighting must be arranged to give adequate illumination where physical and chemical hazard exists. Fireproofing determines the plant arrangement and switch room. Heating and ventilation. Their intake should be positioned in such a way that it should avoid the risk of drawing toxic or hazardous fumes. Exhaust may be required for treatment of filter washer, separation, proper access for maintenance and operation purposes to be considered. Roofing. Techniques for layout. There is no single technique leading to the best arrangement in any problem. Layout may be considered at several stages from the selection of the site and arrangement of the plant on it through block layout. The three basic principles of layout planning are: plan the whole, then the detail. Individual aspects must be subservient to the whole and sub-optimization avoided. Plan the ideal, then the practical. The ideal layout is free from restrictions and gives the data. Plan more than one layout. It is seldom that a single layout is best for each criterion. Planning more than one permits comparison and leads to greater confidence in making the final selection. Sequence of activities in layout. A simplified network showing the integration of the plant layout and design activities should be given. Layout analysis methods. Cut out to visualize plant layout. The two-dimensional scale templates or scale cutoffs of unit areas and equipment layout are prepared. Block models. These models are chiefly used to develop the plot plan, floor plan, elevation, major equipment and major pipe racks in the correct correlation with each other. Drawings. For the development and evaluation of the layout, a code relates the basic project information of the equipment and site condition and provides source of data for the final layout. Piping models. For accurate detailed layout of the process piping utility and control facilities. Concept of the plant layout. The process plant, which consists of the various different sections mentioned earlier, should be arranged so as to follow the general route of the raw material to process, to intermediate or finished product stage to dispatch. The entire plot area will be divided into blocks. The size of the blocks depend on the facilities to be accommodated. While locating the blocks and further sub-blocks within them, the following points runs should also be minimum. The layout planning shall be in the sequential order of the process flow so that the piping run is also minimum. The block shall be arranged considering the prevalent line direction such that flammable gases should not be carried by the wind onto a source of ignition. The process unit block shall be centrally located with a straight approach from the main gate. Storage tanks shall be grouped according to product classification. In undulating areas, storage tanks shall be located at lower elevations. Utility blocks shall be located adjacent to the unit block. The main power receiving station shall be close to the boundary line so that the minimum overhead power lines pass through the plant. The electric substations in the plant shall be located in such a way that cabling to major load centers are minimum. The location of power plants shall be near the process or utility block and close to the main receiving station. Flares shall be located upwind of the process units so that the inflammable gas from the plant are not carried towards the flares. Truck loading facilities shall be located close to the product movement gate. Rail loading facilities are arranged generally at the periphery of the plant. The effluent plant shall be located away from the other units on the down elevation. The preferred location is at the lower elevation than the other plant units in order to facilitate gravity flow. The fire station and fire water pump house shall be at a safe place away from hazardous areas. The fire station shall be near the main gate with a straight approach to the process units and other critical areas. Two adjacent process unit locations shall be decided based on the annual shutdown philosophy for the maintenance of the unit. If the shutdowns are be at different times, it is preferable to increase the distance between the two units so that the risk for the operating units due to heat jobs in the units under shutdown can be minimized. Also, this will facilitate easy maintenance. Process units shall be located on the high ground. The adjacent neighborhood installations, if any, shall be taken into consideration before fixing the plant layout. The limitations imposed by the neighborhood facilities cannot be ignored, for example, an ignition source, flares, furnaces or heater, dusty operations and cooling towers shall be oriented depending on the prevailing line direction. The first two shall be located upwind of the process units and the last two on the downwind directions of the process units. Due consideration to the construction and erection of the plant shall be given while deciding the plant layout, especially tall towers, reactors, furnaces, etc. shall not be in congested areas and sufficient open spaces shall be provided for erection at any stage. Equipment requiring frequent maintenance shall have easy accessibility. So also equipment which needs removal of parts and also for free access for hoisting equipment. Provisions for future expansion shall be considered. It is preferable to have similar type of facilities with adjacent space for expansion adjacent. Care shall be taken to install the expansion facilities without any disturbance to the existing facility. Roads in between for the purpose of access and safety should separate the blocks developed. Firefighting facilities are to be provided on these roads. There shall always be an alternative approach for firefighting and maintenance in case one route is blocked. The layout shall be so designed that truck traffic inside the plant is minimized. Boiler house, air compressors, fuel oil facilities shall be grouped into one block adjoining the process unit blocks, so that spreading of various utilities can be avoided and also facilitate easy operation. The layout shall be designed so as to minimize the capital cost for earthwork and pavement, special foundations, and the extent of a vacant lot as wasteland. Equipment location drawing. Equipment location drawings for plot plans show the exact location of equipment in relation to the plant's physical boundaries. One of the most difficult concepts to explain to a new process technician is the scope and size of modern chemical processing. Most chemical plants and refineries closely resemble small cities. They have well-defined blocks and areas connected by a highway of piping and equipment. Equipment location drawings provide information about the neighborhood. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.